we've showed some of the serverless computations that's offered. We've showed you a little bit about the user-defined functions. Now I want to highlight a couple other functionalities and then finish off with a brief overview of our public Explore details. So in addition to the programming environment where you can actually run notebooks, we have the ability to display Jupyter notebooks as TileDB arrays. So if I actually launch a dashboard first, we can show you that in a live environment here, you can actually view the whole dashboard in an interactive fashion. So if you have coworkers or end users that maybe aren't as sophisticated in the programmatic sense, and don't want to get into a notebook and see the actual code, you can render visualization outputs live in the system. And these outputs can be three-dimensional outputs, they can be tabular outputs. Here we have a nice example of a 3D rendering with our Babylon.js plugin of a LiDAR data set. So very easy, interactive, you can move it around, tons of flexibility here directly. And you can, like I say, you can do almost anything here. We'll walk through a couple more dashboards in a second, but I want to actually show you what this actual notebook looks like. So you can see the output here is just the visualization in the rendering. But if we actually go to the notebook and we pull up the dashboard, we can actually see the preview environment, what we're actually doing. So this is an actual Jupyter notebook with the code available here, but in the dashboard environment, of course, all the code is rendered. So we import it, we open the array, we slice some details, and then we just output our Babylon.js plugin. So any type of Jupyter plugin that produces output, whether it's a Pandas data frame, whether it's Babylon.js, whether it's Mapbox GL plugins, anything can actually produce the full output and render right here. And it's very easy to toggle whether a notebook is a dashboard or not. From the settings page, we have a very simple dashboard option where you can toggle whether this will present itself as a dashboard or not. So as you're working on things, you want to create something for the end users. Once again, you can just toggle it here. So let's open up a couple other examples of the different functionality that we have in the system. The first example that I'm going to show you is a dashboard that actually has interactive input. So we use this as an actual clinical example for a clinical use case that one of our users had, and we allow you to actually have an arbitrary amount of inputs and outputs, and then you can render things live. So in this case, it's a tool that does genomic gene lookups that maps ensemble gene information across referencing with the OMIM, and you can give it a genomic position. You can pick the genome version. You can give it a gene. You can require if things are not. So if I submit this, then we on the back end, we actually perform the queries that are required to do this, and then we render the tabular output that is here. And again, full flexibility. So if I wanted to switch this to the BRCA1 gene, you can do it, and then you can get all the details back. So you can have all different types of interactive input that you would like to have. Again, 3D visualizations, tabular output, a lot of flexibility here. Now, this was all written in Python. So the last notebook that I want to highlight for you is actually a Shiny dashboard that we have. So with our integrations that we have with Jupyter Lab, we actually built out some dashboard functionality to integrate Jupyter Lab and Shiny dashboards. So not only can you build Python notebooks, but anyone that's familiar in the R ecosystem has probably built out dashboards. You can simply build anything you'd like. Here we have a complex Shiny dashboard that one of our employees presented at the Use R conference a few months ago. So you can render the results again in a tabular form. You can also render it. Actually, I need to run a query. When you run the query, you can then render the results in tabular form. If you want a data table like output, you can plot it with the numerous Shiny plot plugins. And you can go from there. So the sky is the limit about what you want to do, interactivity, full Shiny integration here, and a lot of advanced functionality that can be built out of this system. So in addition to the dashboards, the last asset that we have in the system that we've rolled out recently is machine learning models. So with machine learning models, we actually let you store your machine learning model, whether it's in TensorFlow, PyTorch, Scikit-learn, or others, as a TileDB array. So once again, we can store notebooks as arrays, we can store UDFs as arrays, and we can actually store machine learning models as arrays. We've built direct integration and plugins with again, some of the most popular frameworks like TensorFlow here, where you can actually store your model as a TileDB array. And one of the very nice things about this is you gain all of the functionality that we've gone over with the notebook. Of course, the data management aspects, the description, the hashtags, the details, the sharing capabilities, the audit log capabilities, but also most importantly is the versioning support. And we're going to be rolling out some UI tweaks soon to actually highlight the different versions in the UI over the next couple of weeks. But machine learning models, much like notebooks and UDFs and arrays themselves, have the versioning baked into the underlying format. So as you train your model today, and you make a change, and then tomorrow you train your model again, you can actually very easily A/B test the model on predictions. You can use different versions of the model. What was it a month ago? What was it today? So as you're updating your machine learning models, all of that is baked into the APIs that we have, and then also will be baked into the UI for visualizing that relatively soon. And the same thing goes true for notebooks. As you're updating a notebook and you're showing it over time, you can go back in time either using the Jupyter checkpoint system, or we're going to show the preview with the different versions pretty soon in the UI, allowing you to update the notebook, but always link to a specific version so users have a consistent view of that. Of course, with machine learning models, we have a dedicated preview based off the model type and the model integration, showing the relevant details of what this model is. We also have the model metadata associated with this, and any arbitrary metadata that you might store on the model, which is quite important in the machine learning business. I should also note that we have integrations not just with machine learning models, but also with the different dataset APIs. So you can perform very efficient near zero copy or zero copy in many cases training of the model or predictions of the model by storing your data in TileDB, storing your model in TileDB, and then you have seamless integration inside TensorFlow, PyTorch, scikit-learn to do your training and go from there. Now, all of these functionalities that I've highlighted so far have been looking at the assets that you yourself own. But of course, TileDB Cloud is a collaborative environment. So we also have this Explore page where you can view all the public data sets, notebooks, dashboards, UDFs, and machine learning models that are in the system. And this is available not just for the SaaS product here, but also for enterprise users in your own environments. You have full control over the flexibility of when you want to make things private, when you want to share it with certain groups, when you want to make it available to organizations as a whole. And so this makes it super easy to come in here. You have all the same functionality around filtering, searching, exploring in the system, looking through all the different examples. You have public notebooks in the system that you can view. You have public user-defined functions, public dashboards, and public machine learning models. So all of the examples that we've shown today, we will make available under this Explore tab and the various components for you guys to view later on in the system. There is one final detail on the arrays that I want to highlight, a feature that is available to enterprise users, but is mostly available for the SaaS product. And we have some customers that we've been beta testing with this with, and that is our pricing feature. So in TileDB Cloud, we have the ability to monetize your data and code in the system. So this means not only can you share your data and collaborate with others, but through our marketplace functionality, you can build out the entire an entire ecosystem of your own by selling your data right here in the platform. So we use Stripe on the back end for everything. So assuming that you go through the steps of creating Stripe accounts and proving yourself that you're a real user and going through all of the security hassle that Stripe requires, you can then easily monetize your data by simply click add pricing. Today we support 2 pricing types, but we're working with customers to add additional options on this, and we'd love to hear feedback from what you guys see. But the pricing allows you to add a premium to the array itself. So with TileDB Cloud, it's a pay-as-you-go model for basic access. We allow you to add a premium to your array so that users that want to access your arrays have to agree to the license terms that you add, and then you can easily add a rate, an egress rate. If you want to say make it $1 per gigabyte and say $10 per CPU per hour, you can simply save that, and then the pricing would be added to the array and show up here. For the sake of this example that I'm on, I'm not going to add it now. But all of this is also available for the notebooks, for the user-defined functions, dashboards, and even machine learning models. The whole system is baked into it because, once again, everything is stored as an array. So you inherit all the functionality directly in the system.